Hello and welcome to my tutorial section today. Today we are going to look at a very unique case here, as you can see on my screen. We are always confronted with in 3D modeling in modeling parts that are not uniform. This is a typical kitchen vent. It can also be used as industrial vent, where you have a series of pipes that are connected and a series of like junction pipes that you have to use and make connections to all the vents. We have very uniform dimensions here. Starting from this, that looks quite different from this part of it, and looks quite different from this part of it. So this is a normal thing that can occur in realities. Modeling it maybe not like can not be impossible, but sometimes can create a little bit of challenges. But in this case, we have just made it a very simple part. So, but it's always one way we can do this type of modeling is simply by using surface modeling. So we are going to be showing this tutorial sections how we just quickly model a typical vent of this nature. So let me lift up my tree here. I will lift it up to this part. So and then uh, the standard planes. So you can see the front plane there. Pretty. Yeah. Let's see. And then that's the top plane. Yeah. So, all right. And that's the right plane. So we created first of all, we have taken well, sometimes you have to just copy. It can be possible that you need to copy uh, yeah, the other models that have been done to use and design your own uh, connections. Here is common events modeling. Okay, so we created based on measurements. We have offsetted the right plane by 50 mm, offsetted the top plane by 50 mm, and offsetted the other side of the right plane with 150 mm. And then we started. Then I can show a bit of what have been done here. So we modeled the face here. Let's see, which was based on a sketch. Let's look at this sketch. So this sketch by placement is from the origo to this midpoint of this sketch is 80 mm, and the front side, that's the front side of it is six is a square. That's 60 mm by 60 mm. Okay, so I don't want so these ones are very easy. If you would have wondered what I've done, I just simply have to go to the offsetted plan. If I hide this sketch, so you see quickly what you have done, so we can save time. Hide the sketch. Okay, so here, hide. Oh, okay. Oh, yeah, that one was not still hidden. Okay. So, just go to the page here and do a sketch, and then so establish a new sketch. So, so, and then mention this to 60, and make all the sides equal. So, and then place this exactly. Create a horizontal. Wait, I'm just making it. It's not okay. So and then dimension this one to be 80. 80. So and then dimension is to be 80. So then we come out of sketch, so you can see it. Then we go, I went straight to surface and did a planar surface, yeah, and then I pushed it. So I have this face, but I have to clean it off because I already done this before. So we can use the former sketch to save a lot of time. So can remove this also. Alright, so you cannot see, you cannot remove this here. Okay, this is exactly the same way I've done for the plane. The top plane was the top plane that was offsetted by 50 mm. So if I open that top plane, um, if I open the sketch on it, you'll see the sketch. So that sketch was done, and I also used the planar face to get that. Then I moved on to the next ones that was done by that was, yeah, offsetted from the right plane by 150. So and then you can see the sketch too. That's the sketch, and then you can see the relationship here. It is, you can see the other face and the second and the face offsetted from the right by 50, offsetted from the top by 100, the top by 50, and offsetted, that's the one we are in the sketch now, from the right plane by 150. Hope you get me right here. So now we have three faces. Then we have to do a 3D drawing, and then I have to explain because I already have that drawing on it, sketch on it. You go to a sketch and then take a 3D sketch, because it's only the 3D sketch that can give you the guide curve that will fit in. You can also do it in a 2D sketch, but I will explain, because the reason why it can't 2D sketch can't really work on it is because for this guide curve to work, to be effective and give us exactly the curve we want, we have to do a pies relationship at this point and draw it up to doing a pies relationship at this point. Yeah, and the center. And most times it can happen that the alignment of the two surfaces are not at a normal plane against each other. So so most times it's easier to use a 3D sketch, because a 3D sketch is easy to work with in an open yeah, in an, like we say, that open universe, because it can go in all directions. Okay, so but let's look at the sketch we have already done before for this. And let me see if I think I used uh, all right, that was a 2D sketch. So this was the first sketch. So yeah, I used the 2D sketch, but you can also use, depends. I made it as simple as possible, so because this surface and this surface are in alignment, so I could penetrate with just a 2D sketch from this uh, surface to this surface. So this will now act as my guide curve. So let's come out from the sketch. Yes. Let's see. So you know why I have to use the guide curve is that if I remove the guide curve and I try to join the two surfaces, it will be normal to each other. So it won't give me the exact flow of the pipe. But by adding the guide curve, which you select, because is an arc, it's spline line connected to a horizontal line and a vertical line, so it doesn't go to select at a particular at the same time, but you can use the selection manager, and then you can select all of them, all the curves, and then you approve it, and then you can see the flow. Yes, and then you have to watch your pins, if they are properly aligned to each other, that's to the two surfaces. That's done, you can just approve it, and then we get a flow like this. Okay, now the second challenge will be getting this surface to build a loft with this surface, because lofts also work with the principle that the faces, the sketches or the surfaces must be well defined, but this surface is a continuous surface, so we had to do a bit of construction. By going back to this sketch, I can yeah, I can take that so you understand what I did. So we'll go back to the plane that was used to do this sketch, because we are going to flow our loft to the other surface from here. Then, and I can turn it one more time so you can work with it too like this, but it may be difficult because you need it from the other side. Okay, we need to offset this particular point, the particular surface edges. These are the edges of the surface. As you can see, we need to offset it, but the thing is this, we need to, oh, okay, that's got me wrong now. Let me see, let me put it to normal, back to normal. That's good. Okay, see whether I got it right. No. Okay, so yeah, okay, so let's flow it one more time. So reverse in the right direction. Okay, then we'll select it from here. Okay, so all right, so we select it one more time, the edges of that surface. So we offset it because we want it offsetted 2 mm from the first from the other, from this surface. So when the loft is flowing from this surface, when it gets to this surface, at this particular point the loft will be wider. Okay, so now then what we now do is this: we convert these ones to construction lines, the offset entities to construction lines. Okay, we reset it to normal for sketch. Once again, I just like it in the other direction. Okay, let's see what I can get there. So, okay, we offset this surface so the loft will lap exactly on this surface. Convert entities. Okay, so we can draw the sketch. So there, draw the second sketch. So there, want it to, but you can still add relationship if it's not snapping it properly. It should collinear. We should add a collinear. Make this both this collinear now, and then add it. Make this both collinear, and then we should now do a bit of cutting here. Cut that surface. Cut those lines. So we got what we want. Yeah. All right. And then yes. So exactly. We want it to, yeah, lap at the appropriate point. So we approve the sketch. So now you can see it. Now what we now have to do is to add curve, project this curve on this surface. So that curve projected on this surface, approved. So okay. Then now hide these planes. So now we are going to now do a loft between this surface and this curve. So let's see how that's gonna work. So insert, insert, insert surface loft. We are taking from this, and then we are going to this. Okay, so we turn it around. It's not at the connection point is wrong, so we bring it right. So now it's right. So you can see the beautiful connection there. So we are now guiding it because we just it's a straight loft. Okay, that's it. But we have to do more work. Break through the center and then check out. Okay, now there is this wall. Yeah, this wall goes through, as you can see at this particular place. So the issue is this: if you want to clean it and form solid, it could pose a lot of problems. So we have to use we have to you trim this wall off, and then we have to, for us to be very sure that it's not going to cause any issues. So so we say standard trim, where the trim tool should not be, the trim tool should be this one, and the surface to remove should be this one. So all right, so it's connected now. Then we can close up, and then we have to knit the surface and form a solid. Go in, surface, knit. Then we want to knit this surface with this surface, and don't forget this area, these surfaces, because they are our first three surfaces. So oh yes, so then we check if it's from the solid. All right, so it's pretty good. A solid. Okay, we didn't say solid, so we'll go back and ask it to form a solid, to create solid and match entities. So let's see where that goes. Okay, so we have a solid now. Okay, now we have to do a radial along these lines, but the thing is that this is very tricky, because if we, after the radius, then we have to shell it out the parts, the solid, to have a thickness. But the issue is this: if you shell before the radius, it's going to be wrong. So you have to add the radius first before the shelling to get the accurate surfaces, or get the surface to be very accurate the way you want it. So we apply, we go back to features, then take out a fillet, and let's say we fillet by 5, manual fillet 5. Then we choose this place, and then you watch out. You see a lot of um, yeah, more features where you can actually decide for it to do the selection. So we have connected to you see the surfaces, connected to start surface, 10 edges, end surfaces, internal right features. So here there are 25 there. We can choose that. So okay, and choose that, apply that. But it's not all of them we really want to uh, we really want to it's not all of them that we want to fillet. Like all these, the first three surfaces, we are not going to fillet them, so that we can be able to shell it. So we'll go back. Okay, from two, let's see. Okay, that's pretty nice. So we'll go back to this one, because that's the one that controls the front surfaces. So we can remove those surfaces, and then we go and say we want this one. Which one is this one? Okay, we want that one out. You can see it, yeah. So in case let me turn it. So you want that one out. Remove it. So and then any face again. Let's see which face it has related. Yeah, that's okay. Then let's see whether we can get other face. We have to look for edges. We don't want this edge. Let's see whether no. So, yeah. So we will have to remove that one. No, we can do it a bit of. Let's see where. Uh, let's see. Okay, I know what happened here. So we just have to remove this because then remove the front. It helps us to move the front one. Remove this front one. So then we remove so then we remove this one. So let's check if it's okay. We can remove it. Let's see. Then we need to remove surfaces here. Some selectors. Okay. Remove this one. Remove this one. Okay, I think 7 should be the next one. Where 7? No, 7, 8, 9. Okay, let's see what we got now. Okay, we still have 1. We have 2 that are wrongly filleted. We'll go back. There are better ways to do this, so I think so. That I will take it in and that. I think this one came from here. This flare. No. We have to select this one. That was the one that affected that one. And we fillet this one by individually selecting this surface. So that one's right, this one's right. We can let's see. I think that one, everything is right now. That's right, that's right. That's right, okay. Oh, correct, yes. Okay. So what's next? We have to shell it. So we'll go to shell, and then we'll shell it with 2mm thickness, wall thickness, and then we select this face, we select this face, we select this face, and then we show preview. So good and nice. So it's done. So that's it. If you want to see how the inside looks like, so okay, so pretty good. All right. So thank you so much for today's tutorial. Bye bye. See you next time.